What's going on, everybody? Welcome back to my YouTube channel. So in this video we are going to be looking at data and data types in Python. If you're a data scientist, a data analyst, or a data engineer, or if you're in any tech field that has to do with working with data, you need to understand that knowing your data type is very, very essential in Python. The data type determines the kind of data you're working with in Python, and it also determines how you can actually manipulate your data. So in this tutorial, I'm going to break down everything you need to know about data and data types in Python. We are going to be talking about different types of data I'm sure you have never heard before. This is going to shock you because a lot of data analysts or data scientists believe that they actually know all the types of data in the world, or they actually know all the types of data in Python. But the thing is, sometimes there are data types in Python that you don't really know. So whether you're a beginner or an expert and you're looking at understanding data types and learning how to manipulate each data type, this tutorial is for you. Now, a lot of people will be asking, why is knowing data type and why is understanding how to manipulate data types so important? Now, I'm going to give you 3 reasons why you should understand your data type in Python as a data professional. Number 1, understanding your data type helps you know how they can be manipulated and stored. Number 2, knowing your data types helps you understand how they affect performance and memory storage. Lastly, knowing your data types and how to manipulate them helps you avoid errors during calculations. You will know the operators that is associated with each data type, and you also know the rules guiding manipulating each data type. Now, before we move ahead, because I know a lot of you are very excited about this tutorial, I'm excited too. But before we hop in, I want you to know that this tutorial is divided into 2 different sections. The phase 1 is where we'll be using a very beautiful slide to actually talk about what data type is. We are going to give you different definitions of data. We are going to explain the various data types we have. Now, the number 2 is the practical aspect. In this practical aspect, this is where we are going to be manipulating our data types. Now, we are going to be showing you, now in this practical phase, we are going to be showing you how you can work with and manipulate your data type. Hey, wait, before we get started, don't forget to subscribe to the channel. Now, see you in the video.
What is data? Data is raw information, fact, numbers, or symbols collected for reference, analysis, or processing. It can be anything from numbers in a spreadsheet to text, images, and even sensor readings from a smart device. So data is any information that is actually gathered from a particular source. Okay. Now we have unstructured and structured data. When we are talking about structured data, we are talking about a data that is well organized, maybe in a spreadsheet. All right. But when we are talking about unstructured data, we are talking about a data that actually has a structure. Okay. That we actually have to arrange ourselves, pre-process ourselves to actually give it that structure. Now, examples of data may include sales record in a store, e.g., products A sold 500 units. Now, when we look at this particular image here, we can actually say this is a data. Now, this is a bunch of different images, okay? As you can see, we have different images, different brands, okay? Now, this is what we call data. So we can actually gather information from this. We can actually say how many different products do we actually have in this image, okay? How many different products do we have in this image, and how many products in total do we have in this image? Okay. Now, this is a type of data. Okay. So data is anything you can actually draw insights or meaning from. Okay. Now, another example of data is photo stored on your phone, finding size, resolution. Now, this is just like a phone gallery, right? When you look at this gallery, phone gallery, we actually have a lot of different images in this phone. Okay. Now, each of these image contains their own information. Each of these image contains their own information, like their name, their size, their resolution, and the rest of them. So all these are types of data. Now let's talk about data types. So one thing you need to understand is that data is actually divided into 2, okay? Which we have 2 types of data, major types of data, okay? Now we have what we call the numerical data types and the categorical data types, okay? Now when we talk about numerical data types, we actually talk about data types that's like our numbers 1, 2, 3, 4, 5. Then when we talk about categorical data type, we're talking about a group or association where we have female, gender, and class. Okay. Now the next thing we need to understand is that the numerical data is further divided into 2. Okay, which we have the continuous data and the discrete numerical data. Now, the categorical data is further divided into two also. Now we have the ordinal categorical data and the nominal categorical data. Now let's go ahead and see what that means. Now, let's talk about the numerical data and its types. Numerical data are data types that can be calculated and measured. This type of data can be quantified. Now, when we are talking about data that can be quantified, we are talking about data like our numbers, okay? Like we have here, we have 0, 2, 4, 6, 8. Now, these numbers are types of numerical data because they can be quantified, okay, and they can be calculated and measured.
Have you subscribed? Please do. Thank you.
Now, let's talk about the types of numerical data we have. Now, we have the continuous numerical data types, okay? They consist of measurable values. It can take any value within a range, including decimals and fractions. Now, when we are talking about data, continuous data, okay, this is when we have our weight and our height. These are examples of continuous data. Now, let's talk about the second data type for numerical data, which we call the discrete numerical data type, okay. Now, these discrete data types consist of countable values. It takes only specific separate values, no decimal or fractions. Now, when you look at this, you can actually deduce one major difference between the continuous numerical data type and the discrete numerical data type. Now, when we look at here, we say that the discrete numerical data type can take any value within a range, including decimals and fractions. Okay. But now, when you look at this discrete numerical data type, we say that it doesn't take decimals or fractions. Now, we give an example like number of students in a class where we have 30, 31, 32, but not 30.5. Okay. Now let's say we have a class, let's say we have a given class, okay, and we have a total of 100 students, okay. There's no way we can say one student is half, okay. So one student is calculated as one, not half or quarter. So this is what's an example of discrete numerical data type. So there's no way we can say we have 90.5 students. It's not possible. We can only say we have 30 students, we have 100 students, we have 150 students. There's no way we can say we have 10.5 students. So this is actually what discrete numerical data type means. Now, another example we gave here is number of cars in a parking lot. Now, when you go to a parking lot, let's say we go to the parking lot in Walmart, there's no way we can see that we have 10.5 cars parked in Walmart parking lot. No, it's not possible. Okay. We can only have 10 cars parked in Walmart parking lots, 20 cars parked in Walmart parking lots. There's no way we can say we have 10.5 cars parked in Walmart parking lots. Now, another example is number of items sold in a store. Okay, so let's say, for example, we have 10 bottles of Pepsi in Walmart store. Okay. Now, at the end of the day, they can only sell 10 bottles of Pepsi, 8 bottles of Pepsi, 5 bottles of Pepsi. There's no way they can sell 9.5 bottles of Pepsi. This is another example of discrete numerical data.
Have you subscribed? Please do. Thank you.
Now, let's talk about the categorical data and its types. Now, before we go ahead to talk about the types of categorical data, let's look at what is categorical data. So one thing you need to understand that categorical data is also known as qualitative data, while the numerical data is also known as quantitative data. Now, these are non-numerical data that are categorized based on quantities, attributes, or identifiers. Now, we have the two types of categorical data. Okay. Now, where we have the first type of categorical data we have is the ordinal categorical data. Now, when we are talking about ordinal categorical data, we are talking about a data type that follows a specific hierarchy. Okay, there's an order, there's a hierarchy. All right. Now, we said ordinal data is a representation of categories with a significant ranking or order. Although the categories follow a certain order, there are not always equal differences between them. For instance, grade. Now, when we talk about grade, for example, like we have our high school, we have our bachelor's degree, we have our master's degree, and we have our doctorate degree. So as you can see that there is a hierarchy in this case now. There's no way you can compare a bachelor's degree to a master's degree, and there's no way you can compare a doctorate degree to a master's degree, and there's no way you can compare a bachelor's degree to a high school degree. Now, even during employment, salaries are being negotiated based on qualifications. You can see that people that have a high school high school leaving certificates, attract lower pays compared to people that have a bachelor's degree. In the same vein, people that has a master's degree or a doctorate degree has the ability or the potential of attracting more salaries compared to someone that just has a bachelor's degree. Now, there's always that order there. There's always that ranking. There's always that hierarchy. And another example we gave here is customer satisfaction scores, where we have a poor, average, good, and excellent. Let's say, for example, a customer bought an item from Walmart and the customers are actually given the opportunity to rate the product. Okay. Now, there is a hierarchy here where poor means that the customer has a very poor experience using the product. So let's say a customer buys clipper from Walmart, okay, and after using the clipper, the customer rated the clipper poor. This simply means that the clipper did not actually perform the service that the customer was expecting the clipper to perform. So the customer was totally disappointed in the product and went ahead to rate the product poor. Now, average. Let's say a customer got the same clipper from Walmart and after using it, though the clipper was okay, but it was not actually able to take out their ingrown hair. Okay, maybe that was what they were looking at, a clipper that could take out their ingrown hair. But unfortunately, this clipper they got from Walmart was unable to do that, and they go ahead to rate this average. Okay, now average simply means that the product was not entirely bad, but the product was unable to actually satisfy their need. Okay, now the customer goes ahead to rate it average.
Have you subscribed? Please do. Thank you.
Good. Now, when a customer gets the same clipper from Walmart and after using the clipper was able to actually shave him or her properly. But at the end of the day, the clipper left maybe some bonds or something that the customer had to get another product to clear up. Now the customer can say, okay, well, this product actually performed the service I actually got it for, but unfortunately this product left me with bumps or so. Now this customer can go ahead and rate this product good. Okay, so even though this product performed its function perfectly well, but it actually left me with bumps, okay, which I was not actually comfortable with. Now, it doesn't mean that the product is not a good product. It simply means that the product actually reacted differently on the customer, maybe because of their skin type or their health condition. Excellent. Now, another customer gets the same clipper from Walmart and rates it excellent. Excellent simply means that this product was able to actually satisfy the customer 100% without leaving bumps. The customer was very satisfied with the product. The product actually gave the customer exactly what the customer is expecting. And the customer goes ahead to rate it excellent, which means that the product is just perfect. Now, when you look at all these ratings from these different customers, you can see that there is the hierarchy, all right? There is a hierarchy. Now, for a customer that actually rates a product poor, it could be 1 star. For a customer that rates a product average, it could be 2 or 3 star. For a customer that rates a product good, it could be 4 star. And for a customer that rates a product excellent, that means 5 star. So this is what ordinal categorical data is talking about. There's always that hierarchy. There's always that order. So now let's talk about the nominal categorical data. All right, this is nominal categorical data. Now, when we're talking about nominal categorical data, we say this data type represents categories that have no inherent order or ranking. Now, this is the major difference between ordinal and nominal categorical data. While the ordinal categorical data follows a significant ranking, order, or hierarchy, the nominal data represent categories that have no inherent order or ranking. Now, let's say, for example, we have color, marital status, or car brand. Color, where we have the fair, the dark, brown skin color, and the chocolate color, and the rest of them. Marital status, where we have single, married. So for car brands, where we have the Pagani car brands, we have the Toyota, we have the Benz, we have the BMW, we have the Highlanders, and the rest of them. Okay, so this is what nominal categorical data is talking about.
Have you subscribed? Please do. Thank you.
Now let's talk about the main data types in Python. All right. Now, when we are talking about main data types in Python, we have what we call our numerical data types. And in Python, these numerical data types is actually divided into three, where we have our integers, our floats, and our complex data type. Now, when we are talking about our integer in Python, integers are simply our whole numbers. For instance, we have our 5, our 10, our 20, our 200. So integers in Python are just our whole numbers. Now let's talk about an integer in Python is actually denoted by int. Okay, now let's talk about floats. Float in Python are decimal numbers. For instance, we have our 4.2, our 5.4, 100.9, and the rest of them. Now, float in Python simply means numbers with decimals. All right. Now, let's talk about our complex numbers. Now, when we're talking about complex numbers in Python, they are numeric numbers with imaginary parts. For example, we have our 4j, 5i, etc. Now, the next data type we have in Python is Boolean, also represented by bool, Bool. Now, one fun fact about bool is that it is a subclass of integer. Yes, so a lot of people, a lot of data scientists, a lot of data analysts, a lot of data professionals, they don't know that bool is a subclass of integer. Yes, but bool is a subclass of integer. So Boolean is a data type that is a binary data type where we always have one negative and one positive. For example, we have the true false, where true is a positive, where false is the negative. We have yes and no, where yes is the positive and no is the positive.
Have you subscribed? Please do. Thank you.
Now let's talk about string. Now, a string is one of the most popular data type in Python. Now, when we are talking about string, we are talking about a sequence of text. A string is a sequence of text, yes. So when writing a string in Python, you must use the opening and the closing string, okay? Now, let's talk about another data type we have in Python, which is called the sequence data types. Okay. Now, in the sequence data type, this is where we have our list and our tuple. Now, when we are talking about a list, we are talking
Have you subscribed? Please do. Thank you.
about a list is a collection of ordered and changeable items. Now, one thing about lists is that you can always modify a list. Okay, you can always modify a list. A list is modifiable. Now, a list is just like a house that actually holds different data types. Now, in a list, we can have a string, we can have an integer, we can have a float in a string, in a list. Okay, so a list is just like a house that houses other data types. Now, when we talk about tuple is a collection which is ordered and unchangeable. Now, one difference you need to know about list and tuple is that list is modifiable. Okay, so you can actually modify a list. You can add, remove items, delete items from a list, but it is not that way in a tuple. So when you are working with tuple, you need to know that you cannot actually modify a tuple. You need to know that you cannot actually modify a tuple. Now, when we get to the practical phase of this tutorial, you will actually see what we are talking about. Now, another data type we have is set and dictionary. Now, when we are talking about a dictionary, it's a collection of unordered, changeable, and indexed items. Create and print a dictionary. So when we are talking about dictionary, you use the curly brackets when creating a dictionary. So a dictionary is just like a collection of unordered and modifiable indexed items. Now, when we talk about set, a set is a collection with unordered and unindexed items. Now we have when we are talking about sets, we have various types of sets where we are dealing with sets, and we also have various ways you can manipulate sets. Now there's another data type that is quite not popular, but is also called a non-type. Now, non-data type represents a data type with absence of value. So welcome to the practical phase of this tutorial. So in this phase, we are going to be working with data types in Python. I'm going to show you how to work with different data types we have mentioned in Python and how to manipulate these data types.
Have you subscribed? Please do. Thank you.
So the first thing, let's go here and open our Jupyter notebook and wait for that to open up. Now the next thing is let's go and create a new Python file. Now we are going to call this, let's change this and call it data types. Let's say data manipulation in Python. Let's say data manipulation. Now let's work on basic arithmetics in Python. So let's just go here and say basic arithmetics, basic arithmetics, basic arithmetics in Python. Now, when we are talking about our basic arithmetics, this is where we have our plus. Let's not plus. We have our plus. We have our minus. We have our raised to power. We have our raised to power. So let's just go and turn this to a markdown and let's run this. Now, the first thing we are going to be doing now in this situation, we are working with numeric. Okay, we are working with numeric data types, which we mentioned. Remember, in the first phase of these projects, remember in the first phase of this tutorial, we talked about various data types. Now, in this situation, we are going to be manipulating our numeric data types, which could include our integer and our floats. Okay. Now, the first thing we have to do, let's look at addition, our plus. Now, let's say we want to look for 25 plus 80. Let's say we are looking for the value of 25 plus 80. Now, we can simply say print 25 plus 80. And when we run this, it gives us the value. Okay, it gives us the value. Now it gives us the value. In a situation where we don't want to also use the print function, we can simply say 25 plus 80. Then even say 25 plus 80. This will also give us 105. Now we can also use various methods. We can also use assigning of variables. Now we can simply say A is equals to 25, B is equals to 80. Then we can simply say A plus B. We can even say print A plus B. And we can say print A plus B. Then we'll run it will give us 105. Now these are various ways we can actually work with our additions. Okay. Now let's look at our multiplication. Let's look at our multiplication. Now for our multiplication, we make use of our star. Okay, which also stands for our multiplication. Now to do this, we can simply say, let's say print 40 multiplied by 30. Now when we run this, it gives us 1, 2. Okay, but we can simply say 40 multiplied by 30. And when we run this, it gives us 1, 2. Now, another way we can do this, we can make use of variable assignment. Okay, let's just copy this. Let's paste it here. So we say, let's say C is equals to 25, and we'll say D is equals to 80. D is equals to 80. And now let's say C times B. Okay, C times D. Now, when we run this, it will be giving us, okay, this is, now when we run this, so when we run this, wow, that gave us 2000. And that was because we did not change the variables we assigned. So we have to go ahead and change the variables to 40 and 30. Then when we run this again, it shows us 1, 2. Okay. Now the next thing I want us to look at, let's look at division. Before we look at division, let's go ahead and look at subtraction first, which is our minus. Okay. Now we can simply say print, we can simply say print 400 minus 200. And when we run this, it gives us 200. Okay. Now we can also use these variance methods in also doing this too. Just the way we did with our multiplication, we can also use it in our subtraction. But let's just move ahead to our division. So for our division, we work with a slash, a front forward slash, a forward slash this. Now we can simply say print, let's say 400 divided by 50, and this will give us 8.0. Right. Now the next thing we are going to be looking at, let's look at exponential, or what people popularly call the raised to power. Exponential, exponential or raised to power. So for this, we actually use double star. Now, let's say, for example, we want to look at 5 raised to power 2. Now, to do that, we can simply say print 5 raised to power 2. Now, when you run this, it shows you 25. Okay. Now, the next thing we can also do is we can also say print 5 raised to the power of 2. Sorry, 5 raised to the power of 2 and 4. Now, when we run this, it gives us this. Okay. Now, the next thing I want us to look at is modulo. Okay. So let's just take a note here, modulo. Modulo. Now, when we are talking about modulo, the operator is the percentage sign. Now, what modulo does is it returns the remainder when a number on the left is divided by the number on the right. Okay. Now, let's just make this a markdown and run this. Now, let's say, for example, we want to look at what remains after we divide 11 by 3. So we can simply say 11 percentage 3. So when we run this, it returns 2. Okay. Now, when you do the calculation manually, you will know that when you use 3 to divide 11, what remains is 2. So modulo is just like a remainder. Okay. Trying to know the remainder of a higher value when divided by a lower value or by itself. Now, another thing I want us to talk about is type. So type is an inbuilt function that we actually use to determine the data type for any data. Now, for example, let's look for the data type of A. Now, remember that when we got here, okay, here, when we are working on when we are working on assigning variables, we actually assigned 25 to variable A. So now, which means that variable A is housing 25. Now, let's look at the data type of A. Now, let's say, okay, this should be type A. Now, when you run this, it return N, which shows that A is an integer. Which is correct because when you look here, A is a whole number, 25, which means that it is an integer. Now, another thing I want us to look at is converting data types. So we actually convert data types using dot as type. Okay, but now there is also a simpler way we can actually convert data type. Okay, without using dot as type, we can simply call the data type we want to convert it to. Now let's say we actually have A as an integer. Now let's just print A here. Let's just call A and see. So when we call A, it returns 25. Now let's say we want to change this 25 to a float, not from an integer to a float. Now we can simply say float 25. Now let's run this. As you can see, it returns 25.0, which is a float. Now let's go ahead and confirm. As you can see, it returns 25.0, which is a float, which simply means that we have simply converted this 25 to a float. Now, the next thing I want us to look at is variable assignments. Even though we have actually done that above, but let's take more examples on it. Now, when we are assigning a variable, we assign a variable. Let's say we want to assign, let's create a variable x, and let's say we want to assign a string.
Have you subscribed? Please do. Thank you.
Now, let's say we want to assign a string, subscribe to our YouTube channel now. Now we have assigned this variable. Now we have assigned subscribe to our YouTube channel now to this variable called X. Now in a situation where we just want to call out, we want to get this, we want to print out the result of this. There is no need for us to start rewriting subscribe to our YouTube channel now. All we simply need to do is calling X. Now let's run this. Now when we go here and write X, as you can see, it returns subscribe to our YouTube channel now. And please, if you haven't subscribed to our YouTube channel, please subscribe to our YouTube channel now. Thank you. So let's go ahead. So as you can see, it returns subscribe to our YouTube channel now. Now, another way we can do this, we can simply say print X. When we run this, it returns subscribe to our YouTube channel now. Now, remember we talked about type. Now let's look for the type of X. Now let's go ahead and say type, the data type of X. Now let's go ahead and run this. It returns string, which is the data type of X, which is like we mentioned during the first phase of this tutorial, that string is just like our text. Now, the next thing I want us to look at, let's look at string concatenation. Let's look at string concatenation. Now, when we are talking about string concatenation, we are looking at how we can actually join two strings together. How we can actually join two strings or concatenate two strings together. And now remember that when you're concatenating, we can only concatenate the same data type. For example, we can only concatenate string and string, integer and integer. Now, let's say we want to assign y. So let's say string 1 is equals to thank you for watching. Thank you for watching and helping us grow. Thank you for watching and helping Tech Up grow. Okay. Then let's say string 2 would be equals to if you haven't, please subscribe to our YouTube channel. Please subscribe to our channel. Okay. Now you see in the situation where you actually have to use a comma, okay, for a text. Now as you can see, when we go ahead and run this, it will actually bring up an error. So what we have to do here is simply backslash. Okay. So if you haven't, please subscribe to our YouTube channel. All right. Now let's go ahead and concatenate these two variables together. Now to concatenate two variables together, we use the plus sign. Okay. Now to do that, we go ahead and say x3 is equals to x1 plus x2. Okay. Then let's go ahead and print x3. Now let's go ahead and run this. Now, as you can see, it brought us. Thank you for watching and helping Tech Up Go. If you haven't, please subscribe to our YouTube. Please subscribe to our channel. Now, when you look at this, you see that there is no space between these. Okay. Normally, there should be a space between these before the next sentence starts. Now, how can we achieve putting a space between these? Now, what we have to do is let's go ahead and add a space. Okay. We have to go ahead and add a space here. Then plus and add a full stop here. Now let's go ahead and run this. Now as you can see, it reads thank you for watching and helping Tech Up Go. If you haven't, please subscribe to our channel. Now this is the way you can actually concatenate two strings together. Okay, this is the way you can concatenate two strings together. Now let's look at Boolean. Let's look at Boolean. Now let's say y is equals to false. And please always remember to write your true false with a capital letter. The first letter should always be capital. Like for example, if we say y is equals to false, okay, and when we say print y, it will give us an error. See, it will give us an error saying that name post is not defined. But once we come and make this capital and we run this, it will bring up proof. It will bring up false. Okay. Now let's look for the type of false. Type Y. Now when we go ahead and run this, it brings up Boolean, which simply means it's a Boolean data type. Okay. Now let's talk about lists. Now one thing you need to know is that list is denoted, it is denoted with square brackets. So nothing you need to know about list is that it can be modified. It can be modified but cannot be duplicated. But cannot be duplicated. All right. Now let's take an example. I can just turn this to a markdown and run. Now let's take an example. Let's say num is equals to, let's create a list of 1, 2, 3, 4. All right. Now when we go ahead and print num, it gives us, okay, let's just say print num. Now let's go ahead and run this. So when we run this, it brings out 1, 2, 3, 4. Okay. Now when we go ahead and look for the type of num, it should return list. You see, it returns list, which means that this data type is a list. Okay. Now, in the first phase of this tutorial, I mentioned that a list is just like a house that houses the other data types. Okay. Now let's call a variable and let's say my list, and let's say this is equals to 1, hello, 5.6, 4. Now we can go ahead and print. So we can go ahead and print my list, my underscore lists. Now, when we go ahead and run this, you will see that it gets us this. Now, one thing you need to understand is that this list is a list of different data types. Now, for this, you can see that we have our string, we have our int, and we have our float. So now this is just like a data type that is actually housing other data types. Okay. Now we can actually join lists together. Okay, we can actually join lists. Okay, now let's say we have lists 3 is equals to 1, 1, 2, 3, 4, 5, and we say list 4 is equals to 5.2, 5.4, 10.3, and 2.1 and 3.0. Now to add these data types, we can simply say list 5 will be equals to list 1 plus list, no, should be equals to list 3 plus list 4. Now when we print list 5 and run this, it's giving us invalid syntax, and this is because of we did not comment out here. Now let's go ahead and run this again. So as you can see, we have simply joined list 3 and list 4 together as list 5. The next thing I want us to look at is tuple. Now let's say u is equals to 1, 2, 3, 4, 5. Then let's say print U. Let's run this. Now let's check the type. Let's say type U. It gives us tuple. Okay, so tuple is actually denoted by open and closed brackets. Now, lesson I want us to talk about this. Let's look at dictionary. Now, let's give an example. Let's say sdict is equals to, open our curly brackets. We can say car brand, then we say Ford, then we say car model, we can say Camry, then yay, we can say 2005, close it, and print x underscore dict. Now let's look for the type. Let's say type x dict underscore dict dictionary.